like we said, if you know the triangles, you should be able to set up any of the trig ratios that you could possibly need. So we know so far that we have a 45, 45, 90 triangle. And the side lengths of these, we aim to have the smallest side of the triangle equal to 1. It represents like the smallest version of this triangle, without going into decimals, of course, like decimals, where the smallest side is equal to 1. And that will be true for both of these triangles. We're trying to sort of scale them down to be the smallest version. But no matter how I scale these, we talked yesterday about even if I multiply them by 2 or I multiply them by 4, once I set up sine 30, sine 45, sine 60, I'll always get reduced back to these same ratios that are happening every time. So if I know that the 45, 45, this just died. Oh no, it's working. Don't worry, guys. So if I know that the 45, 45, 90 triangle has sides of 1, 1, and root 2, Ryan, if I asked you to set up the sine of 45, how could you do that here? Yeah. What are the side ratios for sine 45? Remember SOHCAHTOA? Someone want to help him out? Sirwa? Yes, that's because opposite to 45 and hypotenuse here are 1 and root 2. So if I know the triangles, I should be able to set up sine 45, cos 45, tan 45, and so on. And similarly, sine 30, cos 30, tan 30, and same with 60. Okay, so that's sort of the idea here, is that if I know the triangles, I don't have to memorize all 9 of those ratios. Okay, and then our other triangle was half of an equilateral triangle. It has measurements 30, 60, and 90. And across from the smallest angle is always the smallest side. And we're making the smallest side of these triangles equal to 1. So this will be 1. The hypotenuse of this triangle is 2. And across from the middle angle, or the angle between the largest and smallest angle, so would be the middle side length. Okay, the largest side should be across from the largest angle. That's how angles and sides are related in triangles. Ben. Yeah. Yeah. Well, if you think about an equilateral triangle, I drew this for you guys yesterday. If this is 1, this is also 1. So what's the length of this? 2. So this must also be 2, right? Okay. So math makes sense, right, guys? No. Okay, so can somebody tell me if I wanted to set up, let's say, cos of 60 here, how would I set up cos of 60? Tony?
Oh, 60, okay.
Yeah.
That would be 1 over 2.
Okay, so this is adjacent to 60, this is hypotenuse, so cos of 60 must be 1 over 2. So there's no need for me to memorize every single ratio. I have it if I know the triangle. All right, good, Tony, thank you. Okay, so there's our triangles. We know SOHCAHTOA from grade 10. We of course also know Pythagorean theorem. So if I know 2 sides of a triangle, I can find the third. In your math travels in trigonometry so far, you guys have been dealing with angles in right angle triangles, or even just angles with trig in between 0 and 90. But today we're actually going to be talking about angles, how we can do trig of angles for angles greater than 90 all the way up to 360. Okay, so in the past we've literally only done like any angles in between 0 and 90. And that's partially because when we were dealing with right angle triangles, you can't fit anything greater than 90 in a right angle triangle, but you actually can have rotations that are greater than 90 degrees. And that's what we're going to talk about today. So there's a couple little setup things that we need to know in order to do this. The first thing is something called the initial arm. And this is essentially where we measure angles from. And it's glued to the 0 degree line. So the terminal arm, or the initial arm, sorry, lies here. And that's where we start measuring angles from.
Hey, are you going to protractor?
No. Do I have an exam or just, yeah, I have an exam. No. Lots of great ideas floating around here.
I'm really just not having.
Yeah, last year, second semester, is that what you're talking about? Oh, nice. Sorry. Okay, then we also have the terminal arm, and the terminal arm is going to, I guess I should actually say, it starts at the initial arm. In other words, it starts at 0 degrees and rotates counterclockwise to measure an angle rotation. Okay, so for instance, Oliver, can you give me an angle measurement greater than 90? Okay. So if I want to measure, for example, 91 degrees, I will start my arm at 0, and I'm going to measure just past 90 degrees. So it'll probably be like right here, for instance. And that this angle inside here that I've rotated should be 91 degrees. Okay, so that's what 91 degrees will look like. The rotation from 0 around to that rotation. Okay, and of course, this is just an approximation. This isn't perfect. But yeah, 91 is going to be just past 90. Rebecca? It is break at 2. A little over eager there, Lauren. That's okay. No, I appreciate you guys reminding me because I forget a lot. Lauren? You will not need a protractor. We are just going to mostly sort of estimate these locations. If you feel like you want a protractor to like perfectly place them, I mean, you can bring one if you want, but you don't need it. Okay, so those are the first 2 things that we need to know, terminal arm and initial arm. Terminal arm, think of as a rotating arm. Initial arm is glued to the 0 degree line. It will always be there. That's where we measure angles from. Okay, so trig with angles over 90 degrees. When we find trig ratios, so sine, cos, and tan, of positive angles, so I'm talking 0 and forward, we are rotating, like I said, counterclockwise from 0 degrees toward 360. And there's this rule, it's called the cast rule, and it helps us actually determine which of our ratios will be positive or negative in each quadrant. So when we were doing grade 10 trig, we were dealing only with angles in between 0 and 90. And we always got positive ratios out of that. But when we do angles over 90, sometimes the ratio of sides can be negative or positive in different quadrants. So just so you guys know, we have numbers for each of these quadrants, and the numbers are quadrants 1, 2, 3, and 4. And the CAST rule, CAST is actually sort of like an acronym that helps us remember which trig ratios are positive in which quadrants. So we start the CAST rule in the fourth quadrant and work our way spelling the word CAST counterclockwise. So we're going to spell the word CAST, C-A-S-T. And I'm going to take you through what these represent, and we're going to sort of do like a couple little examples on our calculator. So if you have a calculator, I'm going to ask you to grab that out. You should be in degree mode. DEG or highlighted D for some of you guys. Trying to figure out how to switch mine now. There we go. Does anyone need help? Yeah, who said that? Angela? If you have this calculator, I can show you how to do it. Anyone else need help? We're all in degree mode. We're all good to go. Okay. All right, so A, let's start in quadrant 1. A stands for all, and that means that all trig ratios will be positive in this quadrant. So I'm going to choose somebody. Andy, can you choose for me an angle between 0 and 90? Any angle? 89, sure. So I want you guys to do a little test in your calculator. And as you're testing, I want you to just pay attention to whether you get a positive answer or a negative answer. So I want you to do sine 89, then cos 89, then tan 89. And I want you to tell me what you get. No, each individually, and just pay attention to whether you get positive or negative answers. That's hypotenuse.
Oh, well, how come you don't use that then?
Actually, I don't know what that is on your calculator. I have to look. Okay, so you should, if you calculate sine 89 and then cosine 89 and then tan 89, you should get all positive answers. And that's because all trig ratios between 0 and 90 will give us positive answers. Okay, so this is the quadrant where theta is between 0 and 90. Matt.
So is this like the graphing? I think I can out like S would be negative, right? Like
Some things will be negative. Well,
I
guys,
thought it was like a graph.
okay, we'll see based on our angle that we test in between here. So I need somebody to choose an angle between 90 and 180 for me. Rebecca? 90 and 180. $126. Okay, we are going to test sine 126, cos 126, tan 126. I want you to pay attention to whether you get negatives or positives.
So smart.
Okay, so I heard only sine is positive. Did everyone else get that? So sine of 126 was positive, but cos and tan of that angle were negative. So what does the S stand for? Sine. So if I take the sine of any angle from 90 to 180, I will get a positive ratio. But if I take the cosine or the tan of anything between 90 and 180, I will get a negative. And can anyone guess what T and C stand for? Tony? Okay, so can somebody predict for me what might happen in the tangent quadrant? Matt? So in the tangent quadrant, tangent is positive and sine and cosine will be negative. You can test this on your calculator, choose any value between 180 and 270, plug it in, and you will notice that sine will give you a negative ratio, cosine will give you a negative as well, and tan will give you a positive. Okay, so this is for angles between 180 and 270. And any guesses as to what will happen in the cosine quadrant? What will be the results when we test a value? Ben? Okay, so cos will be positive in its own quadrant. Tan and sine will be negative. And that is for any angle that you would choose between 270 and 360. Wouldn't what? Yeah, but cast is actually sort of like a word. So the cycle will repeat again. 360 covers a full rotation, and then if I go further than that, I'll just be back in the first quadrant again. Yeah. Yeah. Okay, so I heard somebody say, are we gonna have to memorize what happens in every single one of these? No, you don't, because CAST should tell you which trig ratios will be positive for which angles in which quadrants. Yeah, that's why CAST basically tells you everything, right? But we just need to know obviously what CAST represents and what it tells us. Okay, so we've got that. The last thing that we need to know to kind of set us up for the types of questions that we're going to do today is reference angles. So any angle over 90, so in grade 10, we only did between 0 and 90. Now that we're going to do past 90, any angle over 90 needs to have a reference angle. And I call this its buddy. Needs to have a buddy. And the buddy angle will be between 0 and 90. So it will be an acute angle that will help us determine the exact value when we're given an angle over 90 degrees. So the buddy angle is always the angle between either the terminal arm or the closest x-axis. So the buddy angle will be between the 0, 360 line or the 180 line. So as an example, we're going to use 300. So firstly, I want to draw 300 in its approximate rotation position. So if I start at the initial arm here at 0 and I rotate counterclockwise to 300, 300 should be about 30 degrees past 270. So 300 will rotate about here, let's say. Okay, so this will be about 300 degrees. And when I go to find the reference angle for 300 or the buddy angle, I'm going to find the angle between the 0, 360 line and my terminal arm. So this is the reference angle inside here. It's the acute angle between your angle and the horizontal. So what's the angle between 300 and 360? Oscar? Yeah. So my reference angle, I'll calculate by doing 360 minus 300, and we'll get just 60. Okay, so that's our reference angle. Okay, if my angle is over in this quadrant or this quadrant, I'm going to use the 180 line to find my reference angle. Okay, so we'll see in a couple other questions how we can find the reference angle for different locations. I do not need a reference angle for angles between 0 and 90 because only angles above 90 need a reference angle. Matt? So always the buddy angle is the angle between the terminal arm and closest x-axis line, so closest horizontal. So either the 360 line or the 180 line. Okay, so this is a mistake I see a lot, actually, what Matt just said. People use 270 or 90 to find their reference angle, and that's not correct. So always make sure you're using one of the horizontals, either 180 or 360. Yes, so your reference angle should always be between 0 and 90 if you found it correctly. Yep. I'm not sure what you're asking me.
Like if it was, I don't know, it's not like if it was 200,
Yeah,
would it be 20?
well, we're gonna do a couple in those quadrants anyways, so maybe that will answer your question. Okay, so before we go on our break, let's do 250. So I wanna actually place 250 in the approximate spot where it's going to be. So I'm just gonna draw out my little quadrant grid here. You are going to draw this many times by the end of this unit. And I'm going to measure a rotation of 250 from, of course, 0 degrees. So that should fall about 20 degrees before 270. So it should fall maybe like right around here. And that would be my rotation for 250. Now, when I'm trying to find the reference angle for 250, I'm going to find the distance between the closest horizontal, which in this case is 180, and my arm. So what is the angle measurement in between 180 and 250? Or how could I calculate the angle slice here? It's 70. So I can calculate this by doing 250 minus 180. And that will give me that little slice in between there. That will give us 70. So that's our reference angle. Ben. Okay, it's 2 o'clock. Do you have a question?
Oh, no,
Okay. Yeah. I'm not sure what you're asking me. Yeah, okay. Okay, guys, I'll see you at 2:15, okay? We're gonna keep going here. So let's do the next one here. We're going to plot 120. So show where that lies when rotating from 0 counterclockwise. So I'm just gonna label out each of my 90-degree rotations here. And then we're gonna measure from 0, 120 degrees. So 120 should be about 30 degrees after 90, which places it probably somewhere about here-ish when measuring from 0. So that's 120. And when we go to find the reference angle, this is closest. Remember, we're not using 90 or 270. We're just using the horizontal. So is this closer to 180 or 360? Lauren? 180. So I want to find the angle measurement between 120 and 180. So how do I find that? Tony? Yep, perfect. So 180 minus 120 equals 60. It's always just the bigger number minus the smaller number. Okay, we want that angle to be positive inside there. We're just seeing what the measurement is between 180 and 120. Great. So that's how we'll find a reference angle. So now we're going to put this all together with finding the reference angle and also using the cast rule and our special triangles from yesterday. All right, so anytime an angle over 90 degrees has a reference angle of 30, 45, or 60, we can actually use the special triangles to determine an exact value of that trig ratio. So this should be a no calculator thing where we should not have to use our calculator for this at all. And I'm going to ask you on your test, either if you don't use your calculator on your test, you'll have to just use the triangle, or you'll need to show me enough evidence that you know where this came from or where this comes from. So here's sort of the steps of what we're going to do here. If I'm trying to find the exact value of an angle over 90, I'm going to first place the angle. We call this standard position. So we're going to place the angle in standard position. Okay, so I'm going to follow along with that here. So I want to place 210 approximately where that rotation would lie. Doesn't have to be perfect, but in the approximate area. So 210 is probably going to be around here-ish. So we've done that. We are going to then find the reference angle. Okay, so can somebody tell me how I would calculate the reference angle for 210? Lauren. Perfect. So I'm going to find the angle between 180, which is the closest horizontal, and my arm. So in our case, this will be 210 minus 180, and that should give us 30 degrees. And that's this angle inside here.
For 120, you also use 180, right?
Yep.
That's 180 minus.
Yep. Okay, third step, we are going to draw the special triangle. And I know which special triangle to use based on what this angle is. So if I have 30 in here, which special triangle should I use? The 30, 60, 91. So I'm going to complete my triangle just by doing this. I'm going to make a right angle in between that terminal arm and the closest x-axis. And then I'm going to label my sides accordingly here. So across from 30 is always the smallest side. What's the smallest side of this triangle? 1. So I'm going to label 1, root 3, sorry, and 2. Okay, so we know this from our special triangles. And we are finding the sine of our angle, and we can actually use our reference angle to help us with that. So the last step here is to use the reference angle and the cast rule to find the ratio. And I'll show you how we're going to do that. Okay, so use the reference angle and the cast rule to find the exact ratio. So if this is my reference angle, I also want to just quickly write out the cast rule here. So C, A, S, T. We are in the tan quadrant, and I am taking the sine of an angle in the tan quadrant. So what do I know about my resulting ratio here? Is it going to be positive or negative? Emma? It will be negative because sine of an angle in the tan quadrant is negative, okay? So that's what the cast rule is going to tell us. So the sine of 210 is actually going to be equivalent to the sine of 30, but it will be the negative version of the sine of 30 because it's in the tan quadrant. So it's going to actually be equal to the negative sine of 30, whatever that ratio is. Okay, so I decide on this based on the quadrant that we're in. If I were in the sine quadrant and taking the sine of something in the sine quadrant, my answer would be positive sine of that ratio. Okay, so using our special triangle now, if I'm doing sine of 30, I do opposite over hypotenuse. And I know that this is opposite and this is hypotenuse in this triangle. So I will end up with negative 1 over 2 as my answer here. Okay, you can check this in your own calculator, but you shouldn't have to use your calculator to come up with this. So if you check the sine of 210 in your calculator, you should get negative 0.5. Okay, so it's equal to the sine of the reference angle, but the negatives and positives will change depending on what quadrant your angle is in. Okay, so this will take a little bit of practice to sort of get used to. So we're going to try another one here. following along with these steps here. Okay, so tan of 315. So we are going to place 315 in the appropriate area. And 315 should be about halfway between 270 and 360. So 315 is probably like right around here. So that's the first step. Place the angle in standard position, so rotating from 0 counterclockwise. Now we're going to find the reference angle. So is 315 closer to 360 or 180? It's closer to 360. So I'm going to find the angle in between 360 and 315. How do I calculate that? Okay, so the reference angle, so actually it's the other way. Oh yeah, you're right. So the reference angle here is going to be equal to the larger number always minus the smaller number, because we just want that to be positive. So it will be 45. I'm going to label that in this corner here. Ben? No, I don't think that's necessary. I think you can probably figure that out. Yes, because probably what I'm going to do is I'll probably just give you your calculator and then I'll just say, show me evidence that you know where this came from. So I'll have you actually draw the triangle right on there. Okay, so we're going to complete the triangle. And I know that this is the 1, 1 and √2 triangle. So I'm going to label the sides accordingly. And I'm always making the right angle in between the horizontal with a vertical line from the terminal arm. Okay, so when I do this, I would never expect to see a triangle created like this. I'm always creating it with the horizontal as one of the legs of the triangle. Okay, next and last step, we're going to use the reference angle and the cast rule to decide on the exact value. So I'm going to just draw cast here quickly. And we are in the cosine quadrant. What do I know about the tan of an angle in the cosine quadrant? Will this be positive or negative? Tony? Negative. So tan of 315 should be equal to the negative tan of the reference angle, which is 45 degrees. Again, negative coming from the fact that we're taking the tan of something in the cosine quadrant. Rebecca? These are sort of like, once we get into our next unit and actually are graphing some of these things, you'll sort of see these are like special points along like our graphing of this type of stuff. But mostly this is just like, these are sort of just like important angles where we can find exact values from them. There's sort of like special triangles. Again, they come from the isosceles and equilateral triangle. What are we using these for specifically? I am under the, I'm just going to pause this for a second while I go on my little rant. So Lauren said, based on 45 as our reference angle, we are getting opposite and adjacent of -1/1, which simplifies to -1. Okay, so we're going to pause here. And I want you guys to actually try some questions on your own like this. So the first question that we're going to do from the workbook is just placing the angles in the correct locations. So I have a couple questions that I want you to start with here. These should not take very long. One should be really fast. And then 5 ABE are practice of the types of questions that we just did. So I'm going to give you guys about 20 minutes to do this. It should realistically not take a lot longer than that because one is super quick. Let's pause this. Awesome. Okay, so far when we talked about angles over 90 degrees, we talked about rotating from the initial arm counterclockwise. So we rotated from the initial arm this way around. But you can also actually have negative angles. And if you have a negative angle, what it's telling you is you're actually rotating from the initial arm clockwise. So if I rotate, for instance, negative 315 degrees, I would actually start here and rotate 315 degrees in this direction. So 315 degrees in this direction is about like right here. Okay, so this is negative 315 degrees, rotating from 0 clockwise. Okay, so you could almost imagine that if I were rotating in the negative direction, this is like negative 90, negative 180, negative 270, and then negative 360, if you're thinking about negative rotations. So it would make sense that, of course, negative 315 should be between negative 270 and negative 360. Okay, so positive angle rotates counterclockwise, negative angle rotating from 0 clockwise. So far, so good. Can I scroll here? Okay. So you may see scenarios where it actually asks you to find the exact value of sine, cos, or tan of a negative angle. And we actually are going to switch a negative angle into a positive rotation first, and then we'll go ahead and do like all our usual steps. So if we look back at 315 for 1 second, what's the positive rotation that would bring my arm to the same location right here? Oscar? 45 degrees. So negative 315 can actually be changed into a positive angle by adding a full rotation of 360, and that will give us the positive version of that angle that's in the same location. So if I add 360, I actually get a positive rotation of 45. And no matter how I rotate that, whether I rotate it counterclockwise or clockwise, the arm will be in the same position. So if I rotate negative 315 degrees versus positive 45 degrees, this is in the same location either way. Tony?
Is it like the only thing where like positive 45, is there really a point making it negative 35?
Negative 35?
I mean, negative 360.
Well, it's just an understanding of the different things that we can have in as far as like rotations. So I can actually have rotations above 30 degrees as well, like Matt, or sorry, above 360 degrees as well. Matt said, what happens if you go past 360? Well, if I go past 360, then I'm just following along in the same rotation again, that many degrees, right? So if I go 500 degrees, I go 140 degrees past 360. I'm just going to keep rotating around. So it's possible to go past that, and it's also possible to go in the negative direction as well. It's just different rotation, different ways of rotating around. Add 360 to make the angle positive. And what is 360? It's a full rotation all the way around that circle, right? It's the measurement of a circle. So if I rotate my angle 360 degrees all the way around, that's what's changing it to a positive angle. Okay, so if we are approached with a question like this, we will first make the negative angle positive, and we'll follow the same steps that we followed before, okay? So for negative angles, first make them positive, then follow the same steps as before. Follow the usual steps. Okay, so negative 45. I can make negative 45. Actually, let's just place it on here quickly. If this is 0 and I rotate negative 45, that's 45 degrees in the clockwise direction. Now, if I add 360, I can actually find this rotation, the positive rotation. So 45, negative 45 plus 360 to make this positive means that this is 315 degrees. So this should be equal to the sine of 315. Those two are like the same angle of rotation, right? The arm is in the same spot. Okay, so you're gonna then follow along with your usual steps. We have it placed. We're gonna find the reference angle. What's our reference angle inside here? Yeah, it's just 45. We know that already because we rotated that many degrees, but in the negative direction. So it's 45 as the reference angle. I'm gonna complete my special triangle. It will be the 1, 1 and √2 triangle with this as my reference angle. And then I'll use the cast rule. Okay, so cast, starting with C in the fourth quadrant, always working counterclockwise from there. So if I'm in the cosine quadrant, what do I know about the sine of an angle in the cosine quadrant? It's negative. So this should be equal to the negative sine of 45 degrees, the reference angle. And can somebody tell me if 45 is our reference angle, this is opposite, adjacent, and hypotenuse, what is sine of 45? Ben? Okay, so it'll be negative 1 over √2. That should be our final ratio. If I rationalize the denominator, it's negative √2 over 2. Huh?
So the opposite is like the opposite.
Yep. Okay, let's try another one.
Wouldn't it be easier to like move the negative side to 45 just to the same?
No, because this isn't negative because of the negative rotation. It's negative because we happen to be in the cosine quadrant. That's not always going to happen.
Like what I'm just saying, like move the negative 45 for the same.
I know what you're saying, but I'm saying that just because the angle is negative doesn't mean your ratio will be negative. The cast rule determines whether our ratio is negative or positive. Okay? Okay. Okay, place your angle, negative 240, or if you want, you can switch it to a positive angle first. But negative 240 should be past 180, probably like here-ish. Okay, but yeah, if you want, you can just do negative 240 plus 360 and express that as a positive angle. So it should be 120. So this is 120 / negative 240. Okay, so when I find my reference angle, can somebody tell me how to do this? How do we find a reference angle here? Someone that hasn't answered a question today yet. Josh, you've answered one, but go ahead. Subtract what? Not exactly, because I'll get a negative. Okay, so bigger minus smaller. So in this case, we'll do 180 minus 120. That will give us 60 inside here. So that's our reference angle. We're going to make the special triangle accordingly. So draw your special triangle from there. Across from 60 is always √3. And then we are going to use the cast rule. So draw the cast rule, C-A-S-T. We are in the sine quadrant. So what do we know about the tan of an angle in the sine quadrant? Lauren? It's negative. Okay, all of these just so happen to be in not their own quadrants today. So tan of negative 240 will be equal to negative tan of 60. Yes, so if 60 is our reference, this is opposite, adjacent, hypotenuse. And for tan, we want opposite over adjacent. So we will do negative √3 over 1, which will simplify just to negative √3. Okay, so basically, if you have the sine, cos, or tan of a negative angle, not a lot changes. The only thing that changes is that you need to express that as a positive angle first, and then you're just going to follow along with the same steps as usual. Okay, any questions that I can clarify here? Okay, so guys, I want to make this very clear. Just because the angle is negative does not mean that your answer will be negative. Okay? If the angle is negative, it might have a negative ratio or it might have a positive ratio. The CAST rule determines this, not the fact that the angle is positive or negative. Okay? So use your CAST rule to determine what is positive and what is negative. Don't use the fact that the angle is negative.
Wait, so like if it's not in like they like stay in the and like stay in like then like you have to put a negative there.
Yeah. Okay. The last thing that I'm going to talk about today is we're going to touch just briefly in this course on something called the unit circle. And the unit circle is a circle with radius 1. And you will be introduced much further to the unit circle in grade 12 if you decide to take advanced functions. But for right now, the unit circle can help us with a couple things. It can help us with the connection between what we're doing with these rotations and right triangles. So we've been thinking about trig a lot as right triangles, but trig, when we think about rotating, we should be thinking about circles, right? Even Josh said earlier, what's 360? Well, it's the rotation, it's one full rotation around a circle. So the reason why we use right triangles in trig is if I have a point, let's say some point xy on the outside of my circle, what's going to happen is I have some sort of radius, of course, that goes from the center of that circle to the outside. So this is my radius of my circle. And if I create the distance it took me to get over and up to the point xy, what happens is I actually end up creating a right angled triangle in here where this is the number of x units I went over and the vertical is the number of y units that I went up to get to this point. Yep. Yes, so we'll talk about the radius of 1 in 1 second. So this is some rotation theta, right? That we rotate from the initial arm around to this radius arm right here. So when we talk about trig, really what we're talking about is sort of like rotations around a circle and how we create a right triangle inside of that to help us find information about the rotation or about the ratio of sides. So if I were to set up using theta as my reference angle here, if I were to set up the trig ratios, sine, cosine, and tan, if theta is my reference angle, that makes this opposite, adjacent, and hypotenuse. So if I wanted to set up sine of theta, let's say, I know that sine is opposite over hypotenuse based on SOHCAHTOA, but here opposite is represented by y and hypotenuse is represented by r. So the sine of theta would be like y over r. And this is going to be used a little bit more once we get a little bit further into this unit, but it's also useful for scenarios where we have cos, sine, or tan of angles exactly on these cross sections here, like the 0, 90, 180, 270, 360 lines. Okay, so cos of theta is adjacent over hypotenuse, which in our scenario here would be x over r. And tan theta is opposite over adjacent, which in our scenario here is y over x. So you can box these up. We'll refer back to these at certain points. Okay, I also know because of Pythagorean theorem that x squared plus y squared must be equal to r squared, right? The two sides of a triangle squared and added should equal the hypotenuse squared. This is also the equation of a circle. If you remember back from grade 10, we talked about equations of circles and you would plug in radius squared. That's why this is true, right? Partially because of Pythagorean theorem and also because of the radius of the circle being the hypotenuse of the triangle that we can create inside there. Okay, so the unit circle part of this. If you are finding trig ratios of the angles that are directly on these lines, so the 0, 360, the 90, the 180 line, or the 270 line. If I'm using the unit circle, that means that the radius is equal to 1. So as far as an XY coordinate, could somebody tell me if I went 1 unit over on the x-axis and I put a point right here, what would that point be? If I know that the radius of this circle is 1. Ben? This would be the point 1, 0, because I know that the radius of that circle is 1, and it's the point that we cross on the x-axis. So that's the point 1, 0. What would this point be up here? So it'd be the point 0, 1. Good. How about this guy? Whoops. What's this point, Ben? Negative 1, 0. And finally, this one. 20. Okay, perfect. So I'm going to show you guys how we can use this to find the cos of 0 or any cosine or tan of any angle along here. We're almost done, I know, guys, sorry. Seems long today. Okay, so cos of 0. So if I look at my unit circle, at the 0 degree mark, I know that I have, thinking about our unit circle here, I know that I have at this location right here, the point 1, 0. And this is an XY coordinate. What do I know again about the radius of the unit circle? Okay, so if cosine is x over r, I can find cos of 0 really easily because I know that the cos of 0 will be equal to the x at this location over the radius of the unit circle. So what's the x at this location of 0? The x is 1. It's right here. So I'm going to do x over r. In this case, it will be 1 over 1, which equals 1. So if you sub into your calculator cos of 0, you should get 1, and this is why. You can check it if you want. Okay, so similarly, we can do this with any other location on these actual lines themselves using x, y, and r, and this stuff that we came up with up here. So 270, so if we think about the unit circle, here's our unit circle. It still has radius 1, always. And here's our location down here. And we said this location down here is 0, -1. That's the x and y coordinate at the 270 location. So we said tan, based on our knowledge from how we set this up here, tan was y over x. So what is y over x at this location? -1 over 0. What's anything divided by 0? Not 0, it's undefined. So if you type in tan of 270 into your calculator, you might get something like undefined or a math error or something like that. So tan of 270 at this location is actually undefined. That's possible for that to happen with a trig ratio. Well, this is an x coordinate and a y coordinate. So I'm just showing you what x and y are equal to here. No, you don't. Okay, let's try one more. Here's our unit circle. It's radius 1. Sorry, that was bad. Here's our unit circle. It has a radius of 1. We are at the 90 degree location. What was this point again? Up here? This is the point 0, 1. And sine, we said, was equal to y over r. So what is that in this scenario? All right, this is x and this is y. So this is 1 over 1. Gives gives us 1. Check it on your calculator. What is sine of 90? Do you get 1? Yes, that is why. Okay, so a lot of this, Rebecca asked me, what's the point of a lot of this? I can't tell you that there's like a specific real life application for this. The point of this mostly is just to understand why your calculator is giving you out certain values for certain things. And again, it's to help you with that problem solving, critical thinking, visualizing type of skills, numeracy skills, all of that good stuff. Okay, so with this in mind, let's just stop this.